Hello everyone. Welcome to SUSECon Digital 2022. The topic of this session is scale your CI/CD setup for cloud native microservices via InnerSource. So, a brief about me before we start. Currently, I'm working as an assistant director cloud practice at EY. Before that, I led the Cloud Center of Excellence CCOE team at Accenture. I have around 10 plus years of IT experience and I've been working on public cloud technologies since 2017. So, what is the agenda of this discussion? So, we have divided the entire session into four parts. In section 1, I discuss some of the challenges in scaling microservices CI CD adoption. In section 2, I discuss how to achieve standardization in cloud native application delivery. In section 3, we shift gears and we focus on how inner source can help in enhancing adoption across the enterprise. Section 4, we discuss a little bit of conclusion. We conclude the session and we discuss how do we or where do we go on from here. Okay, so without further ado, let us start with section 1. Discuss challenges in scaling microservice CI CD adoption. So, microservices have taken over the enterprise IT by storm. Everybody knows that, right? As per the O'Reilly Microservice Adoption Report, 77% of respondents have adopted microservices. So it is a well known fact now that enterprises who are not able to effectively support microservices will be less able to compete in future. Similarly, enterprises who have adopted microservices are more likely to perform better against any metrics like development efficiency, ability to use new platforms or products or services, collaboration across teams, and sharing of services across applications. So quite frankly, we can now conclude that microservices have crossed the chasm and is a part of the enterprise IT lifecycle. But what do we mean by a microservice? Again, this is not a discussion on what a microservice is and its properties, but at a high level, you can consider a microservice architecture as an architectural style that structures an application as a collection of small services. So these services are loosely coupled. They're independently deployable. You can deploy one service without any impact on the other service B. The services are owned by small teams, and we follow the principle of domain driven design or DDD, and we try to organize these services around business capabilities. So, for example, we might want have one service for payment, one service for invoice generation, one service for purchase, one service for user authentication, one service for logging, and so on. So, what do we get with this microservice architecture? We get a loosely coupled architecture where we can scale each part of the architecture as we need. And this helps in rapid, frequent, and reliable deliveries of large complex applications. If I have to push a change in my logging service, I don't need to deploy the entire application. I don't need to worry about the other application. I can just run my CI/CD pipeline for my logging service and I can get it done. So, this enables an application or an enterprise to kind of be more agile and more responsive to business needs. And also, it helps teams to develop in their own technology stack. In a monolith application, everybody is coding in, say, for example, the same C sharp. But here, for example, you can have one service written in C sharp by a team who is more comfortable in C sharp, and the service written by Node.js and anything else. So basically, we all kind of know what a microservice is, but I just gave a high level overview. What is cloud native? This is very important. So we can consider that cloud is where you compute, where you do the computing, and cloud native is how you do the compute. That is the most important. So cloud native architectures is a model of building and running applications which take the full advantage of the distributed model that is offered by the cloud system, whether it's public cloud or it's private cloud. So all of the advantages that today cloud is offering us, cloud native applications are most suited, best poised to grab those advantages. These applications are normally dealt or built with a focus to exploit the scale, the elasticity, the resiliency or fault tolerance, and the flexibility that a cloud computing model provides. And when we talk about cloud native, mostly, for example, you might have heard about Docker containers or, for example, about Kubernetes. So, from monolith to microservice in itself is a journey, right? Most digital transformation initiatives today have this in some place or the other. So if you see here the monolithic architecture, you have one application which has the UI layer, the business logic layer, and the data access layer, all encapsulated into a single application and a different application for the database. Okay, but when you convert it into a microservice kind of an architecture, you have, for example, one microservice here for the business logic. It can be another microservice for the data access layer. And each of the microservices will have their own kind of associated database. So that is how they are kind of, you can say, insulated from the other microservices. So if you want to, for example, make any changes to the this microservice doesn't get impacted. And there are different ways or patterns of moving from monolith to microservices. For example, you can follow something called the strangler fig pattern, okay, where you gently decouple a monolithic application to microservice and all of that. So this is a high level overview. Cloud native architecture embraces microservices. So microservices are great fit for cloud native architectures as they support most of the core cloud native principles. And you can even consider that one of the main applications of cloud native architectures is microservice. And they have become kind of the key tool for applications or enterprises who are trying to move to a cloud based model. So if you want to move to a cloud native based model, it's better, you are better positioned to make that move if you have embraced microservices. And microservice can arrange an application into multiple independent services, each of which will perform some sort of a specific function. So the purchase microservice will do a purchasing, the logging one will do a logging thing, the user authentication does the user authentication thing. And all of these microservices or these services will communicate with each other either via APIs, well-defined application programming interface, stable interfaces, or use event-driven architecture. So this is kind of the overall idea of microservice. And what we need to understand that cloud native and microservice kind of go hand in hand. Okay, it's not that you cannot have monolithic applications also. There are ways you can do that, but mostly if you see, service based architectures are much better suited for cloud native applications. But at scale, microservice adoption is challenging. So when you have one service, you have five services, you have 10 services, good, it's under control. But the moment you have something like more than 30 services, it's a very difficult thing to manage all of these services. So that is why when a company or an enterprise starts adopting microservices, they start facing a lot of challenges. And microservices do not only add technical complexity to an enterprise, they actually introduce organizational complexity, and they pose a very serious threat on how to scale an enterprise, and we will go over this. So most enterprises, what you will see, every team has their own way, okay, of creating and deploying a microservice based architecture onto a compute platform, maybe Kubernetes or ECS or whatever, forget. This effectively leads to the practice that each of these teams, they have their own pipelines, own methodologies, own guidelines. So there is no standard set of guidelines that is enforced. And every new team, say for example, today I am a new team and I have to set up a greenfield application which I want to be a loosely coupled microservice based cloud native architecture. I will have to run this kind of do the same work, I have to again start from scratch. I have to write those pipelines, containerize my application into a Docker image, then wrap the Docker image around the Helm chart and again deploy to a Kubernetes cluster. So all of this I have to do every time. And this is what makes it very difficult for microservices, because everybody will do it in their own way, right? There is no standardization. And how does DevOps fit in? That is very important. So DevOps is a cornerstone of cloud native application deployment. DevOps, you can say, for example, here, cloud native. If you see some of the four pillars of cloud native application, one is DevOps and CI/CD, microservices and containers. This, right? And DevOps, what is DevOps? DevOps is a set of practices that combines, you can think of development and operations. The most important thing is you cannot achieve a streamlined cloud native application delivery lifecycle without a strong DevOps practice. For monolithic applications, it was still okay. But the moment you have the kind of loosely coupled hundreds of services, so you need much more better, more streamlined DevOps practices. Otherwise, how will you manage these hundreds of services and their interdependence? An effective implementation of DevOps or cloud native DevOps will help businesses to speed up their digital transformation by being more agile and having a high product velocity. So very important to understand that at scale, when you have a lot of microservices, your DevOps kinds of play a very critical role in giving you that edge over your competitors. So we have now understood that while microservice is a good thing, but we have to be very aware that it has its own set of challenges, not only technical challenges, but also organizational challenges. And most of these challenges appear from the fact that everybody is doing things in their own way and they are all starting from scratch. To promote microservice architectures at scale across an enterprise, so when we want to go to some like a microservice first architecture, then we need to have a standardized, opinionated application lifecycle, delivery lifecycle, which is supported by the enterprise platform and toolkits. So this is the idea. So why do we need standardization? If we don't standardize, then it becomes very difficult because everybody is working in silos, right? And if everybody is working in silos, then how do I control? How do I govern? How do I put new practices? How do I push the best practices? In order to ensure that more and more teams in my enterprise adopt these cloud native microservices and these patterns and these practices, we need to provide a very standard, even if it is opinionated, we need to provide a standard way of creating microservices, of deploying microservices, and for consuming microservices. So as an enterprise, I need to guide my developers and engineers. If I don't do that, they will do stuff their own way. How do I provide guidance? I provide guidance using standard templates. I can provide guidance using scripts. I can provide guidance using architectural documentation. And this will help a team to adopt microservice architectures very quickly, because using these platforms and these tool chains that I'm providing them, this guidance and this framework, this cloud native microservice framework, with this I can go ahead and I can kind of, you can consider that I can do a lot more for my enterprise as a whole than, for example, without microservices inbuilt. But how do we standardize, or what do we standardize, right? So we need to understand that we cannot standardize everything in an enterprise. So we need to kind of have some guardrails that, okay, I will standardize this 4 or 5 things. So one important thing to standardize will be the architecture. So we need to provide some generic guidance that the teams can adopt, and this can act as a starting point for their journey. And then they can also customize it or tailor it as per their needs while being aligned to the best practices. So architecture is a very important part. Deployment pipelines, this is also very important. We need to provide some sort of a standard DevOps platform for the enterprises to deploy microservices without having to develop everything from scratch. Standard or reference CI/CD pipelines will go a long way in achieving this. We can also standardize programming practices. We can say no, we need to use AngularJS or React.js for frontend, C sharp for API based, go for something like that. So standard modules we can provide. We can provide good coding styles, comments. We can enforce some sort of standardization in the programming layer also. Finally, which is the most important, practices and patterns. We need to provide a standard practice and pattern set. For example, we need to provide standard tools, standard taxonomy, standard SDLC patterns, and a good project management lifecycle. So all of this is stuff that we can standardize across the lifecycle. So for example, here our main focus will be, say, CI/CD pipelines. So a CI/CD pipeline is, for example, a continuous integration, continuous delivery, or continuous deployment, right? So it's a series of steps that must be performed in order to deliver a new version of software. Although it is possible to manually execute each of the steps, it is better if we leverage automation and then do this as a cohesive unit. So basically, from my source code to my deployment, I can have a pipeline which does it via automation, CI/CD pipeline. But what happens with a microservice adoption, which is scaling up in your enterprise, you end up with something called pipeline sprawl, meaning every single team has their own pipeline and they're doing stuff their own way. Some of them are using static analysis for source code analysis. Some of them are deploying using Helm chart. Some is using one Azure DevOps extension. Some is using a Jenkins pipeline. Somebody is using GitLab. So as an enterprise grow, grows, the same CI/CD pipelines that offer many benefits, they start growing in numbers. And each team has their own way of packaging, building, and deploying artifacts. Even though essentially all of them are doing the same, they are just taking the code and deploying it onto a container platform or to a Kubernetes or cloud native platform. Even though they're doing essentially the same thing, but still there is a there is a lot of duplication of effort, and this is something we call pipeline sprawl, which results in hundreds of thousands of pipelines. So it makes it very difficult for DevOps teams to identify and reuse common execution patterns. Okay, and this diminishes the ability to effectively ship new code. But how to standardize this? How can I standardize pipelines and how can I counter pipelines sprawl? The very simple way to do this is to establish something called reference pipelines. These are standard pipelines which have been created mostly under the governance of a central DevOps board, maybe a DevOps Dojo team, maybe a DevOps practice team, maybe a DevOps architecture governance board. They are in charge of creating, maintaining, and updating this set of pipelines that can be consumed by any team within the enterprise. And these pipelines are actually reference pipelines. You can easily consume them, and they gives a team a way to very rapidly scale up and deploy their application without having to create it entirely from scratch. And at the end of the enterprise end of the cycle, an enterprise will only have a limited number of deployment patterns. If you scan the entire enterprise, you will see even if there are many pipelines, the deployment pattern is mostly same. Either you are deploying to a container, or you are deploying to a virtual machine, or you are deploying to an Azure function or something like that, right? So the idea is to create reference pipelines for each of the deployment patterns. I don't want to create a reference pipeline for every project. No, I will create one reference pipeline for each of these patterns. See, I have a pattern where I kind of package my .NET code, run a few in-unit tests, do some check marks or do some Vera code analysis, then do some Docker image scan using Sneak, and then I deploy to create a Helm chart, and I deploy that Helm chart onto Kubernetes cluster in Azure. So this can be a standard pattern, and I create a template out of that pattern so that tomorrow, if any other person has to do it, they can directly incorporate that. So this will give that reusable block that will help in my microservice adoption. So I have referred a little bit the DevOps Dojo. So DevOps Dojo is some, you can think of it as a specialized DevOps team maybe. Okay, so a DevOps Dojo is mostly a place where DevOps team members will do hands-on training, right? This will provide learners with an immersive environment, and it's usually made up of the product team, product managers, agile coaches, engineers. So DevOps Dojo is just one abstraction, and you can think of them as a specialized team. Okay, that will give you a little bit more benefits. So they will allow you to play around a lot of concepts and then come up with reference guidelines. So a DevOps Dojo can act as kind of a standard enforcer for all of your pipelines. It can be an architecture governance board also. It can be a DevOps practice lead team or COE team, center of excellence. So there are a lot of ways that you can conceptualize it. But the idea is to have some sort of a central governing structure that is doing this for me and promoting this kind of central or extensible pipelines that everybody can adopt. So, for example, this can be reference pipeline. So, what is happening here? My DevOps engineers, or my DevOps Center of Excellence, or my DevOps Dojo, my InfoSec team, everybody have given their inputs, and as a part of this input, I am getting or creating a YAML reference pipeline, a simple YAML pipeline that I'm keeping in my artifact repository, say in my GitHub artifacts. Now, this is all done, right? So the dojo is responsible for enforcing standard guidelines, processes. InfoSec is responsible that all the enterprise-wide security patterns, for example, like static analysis, container image scanning, all are inbuilt in this pipeline. Okay, and my DevOps engineers are basically creating different kind of pipelines based on what are the deployment patterns they have observed by working on the ground. So based on inputs from all of this team, I create this. Then my service line teams, meaning my actual business teams, engineering or DevOps engineers within these teams, they will just go to this repository, they will download or consume this sample YAML and then import it into their own pipeline and then just start coding. Basically, start deploying the application. As simple as that. So you have this reference architecture that helps you in rapidly deploying microservices, which in turn helps in microservice adoption. So if, for example, we have this reference pipeline, what will be a standard architecture or process to deploy a new microservice? So for example, I have a new business requirement, and then an engineering team is developing a new microservice. Say they have created it using C# for that requirement. Now an engineering team has just done it, the coding. Now they will request the DevOps engineer in their team to deploy this new microservice onto the container platform. So in this case, the DevOps team will first go to that repository, to that library, and see, okay, is there a standard pipeline that satisfies my requirement for this use case? Is there a standard pipeline that takes a .NET code, creates a Docker image out of that code, runs all of the static analysis tests, the container image scanning, all of those, the open source vulnerability by white source or black duck, all of this it is doing and then deploying to a container platform. If the DevOps engineer, which belongs to the service line team, finds that reference pipeline, he will download it, then he will use it to create his own pipeline. So as a result of this, so no pipeline needs to be created from scratch. The time to deploy a new pipeline or deploy a new microservice gets reduced. Along with that, you get standardization by default. All the pipelines starts to look the same. All of them have those standard mandatory infosec steps. There is no way you can omit the step because it is part of the base template. So this is the idea. So in section 2, I kind of gave that idea about these pipelines. But at the same time, this in itself has a lot of problems. And here in section 3, I will discuss how inner source can help in enhancing this adoption by some tips and tricks in a way. So, what is inner source? Inner source, you can think of it very simply, is open source within an enterprise. So, it is a development methodology where engineers will build proprietary software which is for enterprises. Okay, this is not open source software, but they will use the best practices from large scale open source projects. So, basically, it is a way that everybody in the enterprise should be able to contribute to a project just like I can contribute to an open source project. This is the overall idea. And this will help, this inner source approach can help the teams in discovering, in customizing, and in reusing existing internal projects. So basically, if I see some problem in a project, I don't have to go and talk to that team. I can just take the code and I can raise a PR or a pull request and get it done. So this can kind of lead obviously to good job satisfaction and all of that, but at the same time, this lets you scale because only a few people working on that code. No, I have the entire enterprise working for me on that project in a sense. So why do we need inner source? Why? So basically, even if I have a central governance board and a central architecture team to govern, but at the same time, it cannot meet all the different development needs. Tomorrow one team will come, no, I need a pipeline for this kind of an approach. Then another team will come, I will need this kind of a pipeline for this kind of approach. So no matter how many pipelines I push as a standard implementation, there will always be special cases, right? Because there are so many things that are happening in an enterprise. So every time a development team will ask for something which is not covered, and then if this is only one team, this central governance team who is developing all of these pipelines, that they will become a bottleneck. So in those cases, it makes sense to have a process by which cross service line teams, some other team who has developed it for their own use case, they will be able to raise a pull request and commit it and submit it to me. So it will make my library bigger. So everybody will contribute to my standard reference DevOps pipeline library and make it bigger. So with this process, everybody will contribute, everybody would collaborate, and everybody will have a chance to submit or request enhancements to the current offerings. You will not have to wait for the existing DevOps team. Typical inner source is very simple. You have a committer and you have a contributor, right? So basically, what will the contributor do? He will create a branch from the main line. So from the main branch, he will create a fork or something, create a branch. Then on that branch, he will commit a little bit of code for his enhancement. Then he will raise a PR. Now the trusted maintainer or the committer who has the privileges for the main line, meaning the actual production deployment of the actual branch, which is the main branch, he will review the pull request. If he sees that everything is okay, he will run the CI. Then if the CI is okay, the jobs are running, the unit tests have passed, everything is okay, then they will approve the pull request and it will merge to the main line. As simple as that. It's a very simple inner source workflow cycle. Basically, you can consider it a very simple development life cycle, but it is giving a lot of ability because this contributor can be anybody. Earlier only I had 5 or 10 committers, but now I have 500 contributors. Each of them are publishing their own. Just like an open source model works so well, right? Because everybody can contribute. Similarly, within my enterprise, everybody will be able to contribute. So this will help in microservice adoption. Because as I said, it is impossible for a central unit to be able to cater to this wide variety of business use cases which is needed by all the development teams. The central team can create a few pipelines, can do the governance, but it cannot scale at that. It will become a bottleneck. But with this inner source kind of an approach, any developer who needs something will download the pipeline. If it's needed, basically he will make a fork or a branch. If he sees that okay, these things I need, then he will modify the requirements. Then he will raise a PR. If when everything is done and he raises the PR, then the maintainer or the trusted committer or the trusted maintainer, he is the part of that governance board. He knows okay, this I will allow, this I will not allow. So based on his needs, based on the requirements, based on the general guidelines, he will see okay, this pull request makes sense, let me merge it. Or he will say no, this pull request is not enough, this is violating the generic guideline that I want, so let's reject it with a comment, let the engineer do it again. So all of these approaches he can give you, and this will in turn result in your microservice adoption increasing. Basically, because the same reference pipelines, you are getting more pipelines in your library automatically, because with inner source model everything is getting scaled up automatically. And advantages, obviously, it provides a strategy for you to deliver incremental business value without increasing headcount. You don't necessarily need to increase the headcount of your team. You become a force multiplier, right? Basically, you act, for example, the host team acts as if it has more headcount than its actual size. You give higher job satisfaction. Everybody gets some sort of a satisfaction out of contributing to a project which is kind of a business important project, and he feels as a part of the wider initiative, and it increases adoption of new tool chains. So it provides a very rapidly easy way, basically, to skill an enterprise in a new technology if you give all of these benefits to commit. And it increases kind of a trust and provides a compound effect. So I tell to the developer, okay, I committed here. He will say, okay, give me the details. Let me commit also. Let me see which requests I can help, which issues I can solve, and all of that. So overall, you get a lot of advantages by advocating an inner source based approach. So where do we go from here? This is very important. So basically, the key learning here is developer experience is the key. Okay, every adoption initiative, whether it is microservice adoption initiative, or is it any other data mesh adoption initiative, or it's a Kubernetes adoption initiative, your developer experience is the key, and you need to ensure your developers are bought into the process. And that can only happen if you provide them a lot of customizable templates to get their job done correctly. So you need to provide them a framework so that they can rapidly deploy microservices. Only then they will be interested. If, for example, deploying microservices is very, very difficult, then they will not like to deploy it, not like to create a new microservice. They will see, if I create a microservice, it will take me 3 weeks to deploy. Let's just continue with the monolith application. And reference CI/CD pipelines or reference deployment pipelines, along with when it's combined with this inner source approach, it can do a huge thing, as I have personally understood from some of the clients I have consulted with. So basically, this gives you that ability to be more than what you actually are. So the reference pipelines is giving you the way to deploy quickly, whereas inner source is giving you the way to build more reference pipelines quickly. So compound effect is awesome. You get a lot of assets with very less investment. And this is the microservice adoption journey, right? So we are developers within an enterprise IT, and this is the target that we want to achieve. We want to achieve widespread adoption of our microservice based architectures. And how do we do it? One is the reference pipelines, another is the inner source. These are the two adoption pillars on which my microservice adoption initiative is resting on. And this will only happen over time as your enterprise gets matured. This all of this, your enterprise will start embracing these adoption pillars, and finally, as a result of the compound effect, after a few long after some time, you will see that your microservice adoption journey is very strong. This is it. Very good. What is it in the future? Where do we go from here? Obviously, we can have a self-service IT catalog. We can create a fully functional architecture governance board, and obviously, as I said, implement inner source patterns. This is what works in the market. Thank you so much for being a part of the SUSECon 2022. I wish you all the best and a great session.